In this video, we will make some important changes to our CPU. Hey guys, welcome back to the channel. So in the last video we made RAM and memory address register. In this video we are going to make some important changes to our CPU before moving on to the instruction set. So if you are new to the channel, I would suggest you to please go back and watch all previous videos. This is 7th video in the series 8-bit CPU on FPGA. If you haven't subscribed to the channel yet, please subscribe and help me reach my 1000 subscriber goal by end of this year. So without wasting any time, let's get started. So first change we are going to make is we will make an initialization function for our memory. So as you see in the saw in the last video, we have a 16 bytes of memory. So whenever we want to load this memory with some initial value, we'll have with current design we'll have to write byte by byte into the memory by generating signals to load the memory on each clock cycle. So if we want to program our memory to hold some data and our instructions, it will be inconvenient for us. So we are going to write a function in our memory mem.vhd file which will read a text file and load the initial value from there. So for this function, so we'll need some header files for that. So we'll use IEEE standard text. We will use text.io from IEEE library. And also we will need text.io from standard library. So I'll just include those. So here we will write our function. I will name this init. Init will accept one parameter which will be file name. This file name will be of type string. This will return a type of memory type which we declared in the last video. This is nothing but a custom data type to hold our standard logic vectors. So in this function, first we will need to open our file. So file open this is inbuilt function. So this takes f status variable. This will be used to store the whether or not the file was successfully opened. So then we will have file data. This will be used to hold the whatever data of the file. Then we will need file name obviously, and the mode in which we are going to open the file. So we are just reading the file, so read mode. Let's quickly declare these variables. So file data variable of file data variable file data will not be a variable but a file. So file data, the type is text. Next variable is f status. So its type will be file open status. This is in inbuilt type, file open. Another variable will be a text line, which will be read from file, and its data type will be line. Another variable we will need is an integer to iterate through the file. So integer, and I will declare its range to be from 0 to 15 because we only need to write operate on like we only have 16 bytes of memory, so we'll need only 16 bytes here, and its initial value should be 0. And what else? Yes, we will need one additional variable called line content. So this line content will be of standard vector of 8-bit. And also we will declare a temporary memory variable. So variable temp memory of type our memory type. So here after opening file we will check if our file was opened successfully. So if f status is equal to open OK, so this is status, then we can read the file. And if f status is open OK, then now we can read our file. So while not end of file, we will loop through the file. And in this loop, we will read each line. First, we will read line from file data to our text line. Then we will read the content of text line into our standard logic vector. So from text line to line content. And finally we will write this line content into our temporary memory variable. So temporary memory of I, we will assign equal to line content. And we will also increment the value of I. And finally we will need to return our temporary memory. So this is the function to initialize our RAM. So let's let's add it to our, not add, let's compile this and check if it compiles successfully. Yes, we have some warnings regarding impure function, but I think we can ignore those for now. So now we will make a text file and make some changes to our test bench so that we know it is being read correctly. So I have written 8 zeros and 8 ones. Let's make 16 lines. And store this as init mem.txt. And in our memory, when we declare our memory object, we will initialize it using our function. So init, and we will pass the name init mem.txt. Note that this init mem.txt, we have stored this file into our HDL directory. So same directory in where the mem.vhd is stored. Let's compile it once more. Now we will make some changes to our test bench. So earlier we were testing all the other functionality, but now we will just comment out these lines and just print the content of our memory so that we can verify that it's actually being loaded from our text file. So starting from memory address 0, we will just So we have made the necessary changes, I think. So let's just compile this and okay, I don't remember actually which was our simulation for memory. I think this should be test simulation 2. This is why you should name your files a little bit carefully, or meaningful names. So Yes, I think this is it. We'll add these signals to a new wave. And run the simulation. Hey guys, after trying to find out the problem, the issue is we are not able to read the file for some reason. As you can see, it is being read as like unknown state. So I'll figure that out and will update you in future videos. So let's move on. We'll just end this simulation here. The next change is to add a 0 flag to our ALU. One of our viewers suggested it. We are not going to use that flag as of now, but in future it may be useful. So let's go to our ALU. Here we will add new 0 flag output. This will be standard logic. And here we will we will set the 0 flag true when our result is 0. So least significant 8 bytes, so 0 down to 7 down to 0. When this will be equal to 0, we will set the 0 flag to 1, else 0 flag will be 0. So this is all it takes to add a 0 flag. I will modify the test bench, not in this video because this is very simple change and it should not affect any other things. So I'll just modify and push the code to Git so you can check it out. Yeah, this was a very simple change. So next change is actually we have to make next change at 3 places. We have to add some tri-state logic. So what is tri-state logic? So whenever we try to drive a signal via like one signal via 2 components, it will go to unknown state. In our CPU we have common bus and all the registers, ALU and control unit is also connected to our bus. So when if 2 registers or 2 different components try to output a value to our bus at the same time, it will go into an unknown state. So for that reason we have to make sure that at any given time only one of the component is outputting to our bus, and all other components will hold the bus to a high impedance state, that is Z value. So we will write logic to make sure that whenever the component is not outputting any value, it will always output a high impedance state. So first is program counter. So in program counter we will add another line here. So after enable we will add output enable. So OE pin, this will be input of type standard logic, and here we are just assigning output we are assigning count to the output line. So here we will write output is equal to count when OE, that is our output enable, is equal to 1, else we need to set it to high impedance state. So our output is 4 bit, so this is the high impedance state value Z. Similarly, for our resistor we have already done this. Similarly, in our memory we have to do it. If here we say if output enable is equal to 1, then data out is we assign whatever memory location. Here in else we will have to write, so for data out, our data out is 8-bit wide, so we will write 8 times Z. And yes, also one more change is in ALU I have written this tri-state logic for carry flag. So it is not actually necessary, because carry will carry flag and zero flag are not connected to any data bus, or we are not basically using them. So just we will remove this from here. So these were the changes. Let's compile them. Let's compile and check if this compiles successfully. Yes. Yes. And yes. So all the changes are compiled successfully. I'm not sure what the problem is with the memory. If I figure out, I will edit this video and add it to this. So for now, that is all. Hey guys, so earlier the memory initialization was not working. It was a really stupid mistake on my part. We need to store the file into simulation directory and not the HDL directory. I was not aware of this, so we did that, and we ran into another problem. For that, I have to overcome that. I have removed the range from I. It was earlier 0 to 15. Now I have not given it a range, and I am reading only first 16. So 0 to 15, that is 16 lines, and initializing our memory. So whatever there is on from line number 17 will be ignored. So now this is working. Let me show you. So if we can see our values like 00FF00. Now if we run our simulation, if we add these signals and run, it should show the contents of our 3 memory locations. So here you can see 00FF and again 00. So memory location 0, 1 and 2 are being displayed here. So thank you for watching this video, and if you like this video, give it a thumbs up. Share this with your friends. If you are not subscribed to the channel yet, please subscribe and help me reach my 1000 subscriber goal by the end of this year. In the next video, we will take a look at our instruction set. We need to study the instruction set before we go on to build a control unit, and after that our CPU will be complete. So thank you for watching this video, and see you in the next video.